welcome. This session is recorded, as you have just noticed. So if you don't want to appear, just turn off your camera. So I think we can start. And in the meanwhile, I will admit people that is joining the room. So, Jessica.
Yes. So thank you and welcome everybody. I will do just a brief introduction of what EIC Communities Project is, so we can then let the floor to to Stella, which is the program manager for the space in the EIC environment. So I am the coordinator of EIC Communities, which is a project funded by Horizon Europe program, and it is coordinated by APRE, the Italian Agency for the Promotion of European Research, together with our partners EURA, the European Business Innovation Network, and ICONS. So our project aims to boosting the visibility and the impact of EIC projects, but also to build communities around them, involving relevant stakeholders and stimulate discussion about deep tech technologies. To do this, it seeks to foster the innovation ecosystem by setting up 3 thematic communities of practice, which are clean tech, health, and industry. Today, we are under the COP, the community industry. So the space is under this category. These communities share tools and resources and serve as platform and co-creation for co-creation and online and physical activities, and nurturing a collaborative multidisciplinary environment for EIC projects. So I share my just briefly the screen so I can present you who is going to be present today during this this panel. So this webinar is called Innovation Lessons Learned from the EIC New Space Portfolio Companies, and we are here together with, as I said, Stella Tkatchova, who is the Program Manager for Space Technologies in the EIC, and also we have Riccardo Benvenuto from Constellar and Geoffrey Lurcy from Greener Wave. So I will give the floor to Stella to start this interesting panel session and discussion about this really interesting topic.
Dear Jessica, thank you for the kind introduction. I would like to thank also Riccardo and Geoffrey for joining us today. I just want to share with you a few slides before. Do you see my slides clearly? Yes?
We see them not in presentation mode, but we see
yes, but in presentation mode, it doesn't work for me.
Okay.
So
Okay.
I don't know why, so I prefer to be on the safe side, okay?
Perfect.
So EIC funds high-risk technology innovations. This is a bit introduction for the audience who wasn't in the previous webinar. We also have a number of space challenges. We have from 2023 space solar energy harvesting, but also accelerated customer-driven innovative space applications. And also we had last year a Pathfinder one, and this year we have the Accelerator one for in-orbit satellite servicing, space transportation, and space-based resilience. The beauty of our annual work program, and it has top-down challenges, but also bottom-up. And today you would see 2 presentations from 2 companies which have applied in the Accelerator Open and have won proposals. Which is a very competitive program with a very low success rate. So I'm really honored to have them on our webinar. Just a few more words about our projects, about our portfolio. It's built by 3 actually pillars: space debris sustainability, enabling space technologies, and Greener Wave is part of it. Earth observation, the company Constellar is part of it. And here, as you can see, actually, the Earth observation part is a very important one. And we will be hearing more about the thermal infrared payloads. We will be hearing about the flat panel antennas and so on. So just one last slide, which is a bit to put more, let's say, to have an idea what we'll a bit discuss today, this is a slide from a 25 years ago. I found in the ESA library a picture. It's my personal. I like very much this slide because in the early days of space technology commercialization, or the early days of the new space industry, there was always the questions coming from the customers, where are the markets? And there were always the experts saying, okay, we know everything. There will be lots of commercial customers coming and queuing. So there were a lot of lessons which were learned for the last 25 years from this process. And very interesting lessons, which I believe that both Constellar and Greener Wave can share what they learned from the market, from the economic, from operational side. So I will just stop sharing my screen, and I would like to start with introducing first Ricardo from Constellar. We will have a presentation, and then first from Constellar, then from Greener Wave, and then we'll dive into the discussion. Ricardo, your turn.
Yes, good morning, everybody, and thanks, Stella, for the invite. So I'm going to share my screen and give you a brief overview of what Constellar is doing. You can see my presentation in full screen, right? Can you?
Yes.
Yeah. Okay, great.
Not yet.
Not yet.
Not
Not
yet.
yet.
It's
Not
uploading.
yet.
It's uploading.
It's
It was
local
working
then.
before, but
Okay, let me just try to reshare again. Maybe it's working. It's not coming.
It's still coming, yes, but it hasn't arrived yet.
Range. Let
Do
me try
you
to
want
change.
to email it to me, or for example?
I'll try to change screen. Okay, now it should be coming, right?
yes.
Yes.
Yes,
Okay,
now we
great.
see it in full screen.
And you can see
Perfect.
also the changes,
Yes,
right?
yes, yes.
Perfect. Okay, thanks. So my name is Ricardo. I'm Vice President of Satellite Technology and Satellite Operations at Constellar. And what Constellar does is that we are trying to build the world's most accurate thermal intelligence platform with a space-based remote sensing. And why thermal, why temperature? Because is obviously a key variable that allows us to quantify risk and thermal risk in climate, and also to monitor infrastructure, agriculture, urban. So to provide very wide use cases for having thermal intelligence from space. And let me show you why again thermal. It can detect anomalies before they escalate. So we can really monitor different kind of infrastructures for predictive maintenance or for reaction to events. It can deliver reliable 24/7 data, also in different conditions, right, from night and day. So thermal images can be captured at all time. And it gives surface insight, not just images, right? We are moving from visible imagery to actually measuring and monitoring chemical and physical variables of our planet, which can give us many insights into what's happening on the land. For example, from agriculture and for crop stress or urban heat islands, but also, especially in this time, also warning systems for tactical defense. Well, our long-term vision is to build a thermal intelligence platform, and this is already an innovation per se, right? We have been constantly innovating not only on our technology but also on our business model. And the point here is having a foundational layer where our customers and research institutions as well can use the data and develop applications based on our data. In this way, we would be powering an ecosystem, right, of commercial customer, of governmental agencies, of research institution to co-develop with us in a scalable and open framework. This would enable a wide range of applications, as I was saying before, to enable real-time monitoring of several infrastructure globally, but also to have then citizen-level stewardship of global resources. Now, our technology is built on 3 key building blocks. One is the proprietary satellite constellation. We have 100 times better performance in space at 1% of the cost, and we do that through many innovation elements. Here there is a lot to say about innovation and about lesson learned. We certainly started with our patented technology that allows to for cross calibration of our sensors in orbit, and this allows to miniaturize the thermal instrument. Actually, our instrument is the first cryo-cooled thermal infrared, long-wave infrared instrument to fly on board the microsatellite platform. And this form factor is only possible through this technology, but also through a mix, a blend of new space approaches with old space processes. Also a blend of industrial grade equipment and COT components with space grade components. So this is definitely there is some key innovations there. The second part, and this is an important also change and shift in business model, which is another level of innovation, is moving toward the digital twin. So we are looking at physical and chemical variables that can be modeled, right? So we want to move toward decoupling the capacity of observations from space to the delivery of the data, to the generation of the time series. Because as long as you are constrained by the capacity of a satellite, this is only partially scalable, right? You need to increase number of satellites, and you need to increase swath, and you need, and this obviously you need to increase coverage, and this obviously comes at a cost. But if you can leverage your proprietary data layer to train models that are able then to fill the gaps, even if there are clouds, even if the satellite is not over the area, also through other times of the day, and reconstructing the diurnal cycles, or changing the parameters of the different land ecosystems below. So this has obviously great advantages for in terms of delivery to our customers, and I've moved towards continuous monitoring. And then finally, as I was saying, the third building block is a thermal intelligence platform that facilitates use of data, use of analytics, co-development of applications across the public and private sector. This is our satellite. It's the first model called Sky-B1. Our constellation is called Hive. And we have, as I was saying, the key innovation here is the accuracy. We have unprecedented accuracy in the retrieval of the temperature, so in the thermometric and radiometric accuracy. We can go down, the maximum, let's say, error is around 2 degrees, but it strongly depends on the lens surface and emissivity and physical parameters, but also on the atmosphere. But it can be, definitely this is the maximum error, but we can go much lower in precision, also to less than 1 degree. And it's always a trade-off, right, between thermometric accuracy, the accuracy of the data, the spatial resolution, the temporal resolution. So we found our key spot to be in pushing down the accuracy. so best accuracy in the world, but then a GSD of 30 meters in thermal, 10 meters visible, but we also have a sharpened product thanks to this combination of sensors. So we have a sharpened product at thermal at 10 meters. And then our imaging capacity is more than 1 million square kilometer per day, with moving toward high temperature resolution. We expect to go to 1 day revisit by 2027 with 5 satellites in orbit. Where are we? We are here, and I'm really proud to show you on the right our first light image. It's from a month ago. It was the first time our payload, our free-flying payload imaged. It's an image of Tokyo by night in thermal infrared. Why am I saying free flyer? Because we already validated our tech, our sensing tech in the space station. We have an instrument flying on the space station 3 years ago. And now in January, we launched SkyB1, and we have SkyB2 launch upcoming next June, so in a couple of months. So we'll have by mid this year 2 satellites already in space and delivering commercially. And what we are doing also in the frame of EIC is then scaling the constellation and looking certainly implementing deltas from FM3 onward. We have a redesign of some elements to move towards more reliable and more operational service, so that we can deliver more available service, so that we can really deliver robust 24/7 monitoring system, and enable the key values for our customers. What are we reaching? We're reaching 100%, 100 times cost reduction in thermal data on demand, unlocking scale with the AI digital driven digital twin, as I was also mentioning earlier. So you can see here, we are also harmonizing. Our data is obviously a jump into what is now available from orbit in this domain in thermal infrared. You can see an example on the left, but we're also harmonizing also our data with the public data sources, so that we have, as I was saying, we have available data at any scale and any time, and enabling us to also generate then insights such as thermal anomaly detections. Finally, I want to give you just an overview. I'm not going to go into a description of each and every element, but this is our technological building blocks. You can see in dark blue our proprietary system, and then in light blue what we use as services from third parties. So we're building the constellation, but we're also building the ground segment, composed by a mission operation segment, a payload data segment, a user segment, and a data platform. And there are really innovative elements in all our subsystems and all our technology building blocks. Obviously, it wouldn't be possible, right, for a small company to build an end-to-end system such this without looking into innovation, without looking into blending custom solutions with off-the-shelf components. And this obviously presents challenges, but it's also what is enabling us the speed, the cost reduction, and then the scale. So that concludes my presentation, but I'm happy then to go more in detail as
Thank you, Riccardo.
Thank you.
Thank you.
Yeah.
Thank you. Geoffrey, excuse me, sorry.
Yeah, yes. Let me share my screen. Okay. Here we go. You see my screen?
Very well. Please go ahead.
Okay, perfect. So, well, thanks also for the invitation to this round table. So Greener Wave is more on the ground than in space. What we are developing at Greener Wave is the next generation of electronically steerable antennas for connectivity. And so the goal of the company is really to provide terminals for connectivity operators around the globe. And the idea is to help them to survive against the mega constellations such as Starlink and Kuiper, which is coming very soon. So I'm the founder and the CEO of the company. I'm also the chief scientist because I used to be an academic researcher. And just a little bit about the company. So we are a spin-off from an academic lab, which is called Institut Langevin in Paris. It's a physics lab. We design, as I was saying, so SATCOM terminals for now on the ground, maybe someday in space, but for now we are really focused on the ground. Our headquarters are in Paris, but we have also smaller offices in the south of France, Sophia Antipolis and Toulouse, which is obviously the main center for space. We are about 120 collaborators at the moment, so this slide is already outdated. And we obviously have quite a lot of patents to support the developments that we are doing. So 13 patent families, but growing. What is very interesting is that we have 27 nationalities. It's not that we select people from different nationalities, but I believe it's the atmosphere of the domain we're working on, space and connectivity, which brings all these talents from remote countries, and it's very interesting. And we also have unique labs in the center of Paris. So if you come to Paris, don't hesitate to visit. It's interesting to have big RF labs in the center
We'll
of Paris.
do in July. Yes,
Cool.
I know, we'll do. We
Cool,
promise.
perfect. Just a bit about the ecosystem. So we come from the CNRS, and we have as shareholders CNRS and various other companies. So Intelsat, for example, satellite operator, is one of our shareholders, as well as Safran. And we have the Public Bank of Investments. We partner with several entities, Intelsat obviously, but also Eutelsat OneWeb and the French MOD, for example. And we are supported, and we thank them a lot by various institutions, obviously the European Innovation Council, but also France, and we are ready to provide the next constellation Iris Square with user terminals, obviously. So just a few words about how we are doing things, because we build the next generation SATCOM terminals, and they are very different compared to what people are doing. If you look at what other people are doing, essentially, when you want to make an antenna that is able to shoot on a satellite and to track it while it's moving, or if the user is moving on the ground, you need to use what people call active phase array. And these active phase array, in fact, they are made out of a lot of integrated circuits. These integrated circuits, they can generate the electromagnetic signals, and they can configure these electromagnetic signals to have a given phase and amplitude, and they will feed a few tiny antennas. And then when you want to make a full terminal, you're going to cut and paste this block, and you will use hundreds of integrated circuits that are all synchronized together and shoot in one direction. And this is what most of the competition is doing. It's called active phase array. And the problem of this kind of approach is that the building block being an integrated circuit, it's very greedy in terms of semiconductor. And at the end of the day, because you use hundreds of them, it's quite expensive and it's very power hungry. So we use a very different approach where, in fact, we don't use these ICs at all. We have a source of electromagnetic wave, which is just like the same source that you can have in a parabolic antenna. And then we use smart reconfigurable materials to control the reflections of the electromagnetic waves and to beam them in a given direction. So the technology that we develop is shown on this slide. It's essentially a printed circuit board where you have identical unit cells, and each of them, they are activated with a very simple component, which is an on-off switch. And when we activate or not this component, we are just changing the way this unit cell is reflecting an electromagnetic wave. And so when you do that on a single unit cell, no one cares. But then when you have a lot of them, when a wave is coming in, you can really decide how you're going to reflect it in one direction, in two directions, or even in all directions using this kind of smart reconfigurable materials. And then when we do these materials, we also do the algorithms that control them. So it's physics and AI, which is mixed together into, as the previous speaker, what we call digital twin of our systems. And the whole thing allows you to have antennas which are much more interesting than the competition, because we use much less semiconductor, so we can lower the price of our antennas, and we can also lower the consumption of our antennas quite a lot compared to competition. So the technology is passive in the sense that we just control reflections of the electromagnetic wave. We don't use complex circuit to generate it. It's very easy to scale at any frequency, yet we are still at the speed of electronics. So it's very simplified, but still high speed as any electronically steerable antenna. And it allows to do very interesting things such as multi-beam, multi-bands, and this kind of application. So we use this technology to connect. We develop SATCOM antenna, but not only. We also are preparing for the next generation, which are going to be telecommunication antennas. And we can use also the technology to detect, because when you do beam forming, you can also do radar applications and these kind of things. So just a couple of words about how we make an antenna from this reconfigurable material technology. We are going to inject electromagnetic waves with a conventional feed, which can be the feed of the front end of a parabolic antenna, as I was saying. And we inject these waves inside a box where we put our reconfigurable surface. So you have few reflections of the wave inside this box, and we control these reflections. And by controlling these reflections, we are going to be able to send one beam or two beams, and in fact, any number of beams that you want in given directions. And all of that is reconfigured in real time. So I won't go too much into the details, but it's extremely simple in terms of mechanism. Now, the physics that is behind is a little bit more complicated, of course. The USPs of the technology, we use less semiconductors than competition, so we are low on natural resources. We are naturally very low power compared to competition, and we also offer much lower thermal dissipation because we simply use less power than competition. Industrialization also is fairly straightforward because it's quite simple. Printed circuit board, basic surface mount technology assembly, and there is really no complex technological step that is involved in our products. We are cost effective because, again, less semiconductor. So we lower both the acquisition cost and also the OPEX because we use less energy. And just to give you an idea of how efficient we are in terms of energy, the beam forming realized with our reconfigurable surface consumes less than 100 milliwatts when you want to beam in any direction. So of course, then you need to add the power of the amplifiers, the consumption of the amplifier of the antenna, and this is what is consuming in the end. But all the control and the beam forming of the signal is done with less than 100 milliwatts. In terms of applications, so the technology is very simple in terms of hardware, and we have pushed the complexity into the software. So we have a fully agnostic and fully software-controlled antenna So it's agnostic because we can, since we control the waves, we can put any front end to our antenna. We can be, we are compatible with any standard and protocol. And then, without entering too much into the details, we make antennas which are single aperture, full duplex. So with the same aperture, we cover the emission and reception of the SATCOM, both in KU and KA band. We can generate multiple beams, and we can control polarization, direction of the beam, frequency, and so on. Due to these nice properties, we are able to do antennas which are compatible both with LEO, GEO, and even MEO constellations in the same aperture. So that's our first product, which is coming on the market this year after years of development. We have it's a KU terminal, so it's going to be able to connect to any GEO satellite in the KU band, as well as OneWeb constellation. Of course, we would like to be able to connect with Starlink, but it's not open. So for now, it won't be compatible with Starlink. And that's so this terminal, just a few words about it. It's the size, so it's typical size of a SATCOM terminal, quite lightweight, around 10 kilograms. And the consumption, for example, if you want to connect to a GEO satellite, is around 100 watts when you have to compare to active phase array, which for GEO satellites are most of the time around 700 watts to 1 kilowatt. So we have almost a tenfold when it comes to GEO connection. For LEO, we are going to be around 50 watts, which is again a tenfold compared to active phase array, which are most of the time around 400 watts. So I know that Starlink is lower, but Starlink is also much closer to the Earth compared to any other constellation. And so, yeah, no need to go too much into the other details, but just in terms of price, we position our product already lower than the competition because we have a unique technology which allows us to reduce the BOM, and we will be definitely much lower when we do one step of design to cost. The EIC project is, in fact, about the development of a new generation of product, which is not in the KU band, but in the KA band. So here you see a prototype of a KA antenna, which is, again, a single aperture full duplex antenna, so meaning that we can cover from 17 gigahertz to 31 gigahertz with a single aperture. And the EIC project is here to help us both to unrisk the development of this single aperture full duplex KA antenna with the grant. So it's this roadmap. So we first have we're developing two sets of antennas with a modular approach, a smaller one and a larger one. And so we are doing field testing in GEO, which was already done. We're going to do this year a field testing with a LEO satellite or MEO. It depends if we work with SES or with Lightspeed. And so the EIC grant is essentially supporting us on the development of the last technological bricks, which was this full duplex single aperture. And the equity is here also because we have asked for a blended finance to help us on the Series B and the industrialization of this next generation of products. Just to let you know, we also know how to make multiple bands antennas. So this was a proof of concept that we did at the last Paris Air Show, where we showed the KU, KA combined single aperture. So it was really an ugly square box, but we know how to make it flat. And this is in the roadmap as well. And in the following years, we will demonstrate an antenna that can cover both KU and KA and give access to all constellation at once in a single aperture. Thank you.
Thank you,
all for me.
Jeffrey. Thank you. So before we go to the questions, I just want to thank both of you for your presentation. Just to let you know, on the 3rd of July, we have a portfolio meeting. So you're welcome to come in Brussels or online and present your projects, both of you,
Okay.
okay, Ricardo and Geoffrey.
Okay.
Now, there is a question for Geoffrey. Can we, from Ragu, can we create side lobes to negate the effects of any spoofing attacks on the main beam as signals, since
Yeah.
it's risk and a little less power consumption, I guess?
Yes, yes. In terms of beam farming with our technology, you can do essentially anything you can do with an active phase array. So we can create zeros in the radiation pattern to avoid spoofing and jamming, just like you can do in any type of reconfigurable antenna. Yes.
Okay, thank you. So I'll start with my questions, which are so the first question was why disruptive innovation is technologies are important to new space industry, but I think you both presentations covered it very well. So my second question, I would dive on the second question, which is what are the major strategic and technological challenges, barriers faced by European SMEs pursuing the design, development, and testing of technologies in the short term? So please think in the short term, 3 years, whether it's components, scaling a product, and in the long term, 5 to 10 years, or in these areas. So I'll start first with Ricardo, and then we'll continue with Geoffrey.
Yes, thanks, Stella. Thanks for the question. It's really interesting, actually. It sparks a lot of thinking also on my side. But certainly, let me take it up by saying also answering to the first question again, because we need
Yes.
disruptive innovation, certainly to speed up innovation cycles. And we need fast innovation cycle. We need a quick time to the market. We need to iterate fast with our customers and adapt from there, right? And in our case, space is always normally dominated by slow cycles. And this is definitely a barrier for the business that we need to overcome, for the technology to overcome to properly serve the business, right? So in terms then of barriers to break, to speed up innovation cycles and to reduce general development cost in order to enable even the viability of the business. One thing is certainly to be solved is the bottlenecks in the supply chain, which is today, especially the legacy space supply chain is dominated by long lead times, right? And also when you go for space grade components is also high cost, right? So the point in the short term is how to break this down in a way that allows you to get speed and momentum, meaning that you need obviously to put together different stakeholders with very different processes, very different heritage, and combine this together and combine their products together, right? So we're an integrator, we're a system prime. So obviously we have a wide supply chain, and that is definitely, I think, a barrier that we have been working to improve. Then maybe something that is more business than technological, but I would definitely say capital access. That's the enabler, definitely. And we know our, let's say, structural, if I can say, issues sometime in Europe. And I think things are going better in the last years, and definitely having the support of different funding bodies and institutes, like in this case EIC, but also there are other programs in Europe. It's definitely helping. What I think is still missing is proper anchor customers that allows you to actually do these iterations and this fast iteration of products and launch of MVPs much sooner together with the customers. That would definitely help companies like ours. And help also the innovation, because then you have immediate feedback from your customers, right? And support. Another barrier is definitely access to labs. That's definitely a point, and also in terms not only of availability, but also of a marketplace for this, right? It's very much onto sometimes personal relationships or still, and I think we need to move in this case, but also for other elements into more of a, and this is more the long-term part, I would say, rather than the short-term part, more into a open innovation kind of mindset, which I think we sometimes lack a bit still in Europe. And finally, I would say I would put definitely as a big barrier for scaling the launchers. We know our access to space today is a bottleneck, how it is dominated by few companies. So we obviously welcome in the domain and in the space the new players. Yeah.
Thank you very much, Ricardo. Actually, you would be soon receiving an email from me, because exactly for access to test facilities, because this is an issue identified not only from you, but from other EIC space portfolio companies. And on the 24th of April, I have a meeting with colleagues from DG DEFIS, and they have actually asked that I gather concrete recommendations from the EIC space companies or the portfolio companies like you, to give me. So if you already have in your mind a list, I need access to these test labs, immediately, please send it to me, because I'm consolidating this information, because they have the, how do you say, they're the policymakers, but they're the ones working, coordinating with the colleagues from ESA and with other agencies, so they would be able actually to arrange, as the way we have, as you know very well, EIC beneficiaries have fast-track access to IOD, IOV flight opportunities too, of the Commission. So
good to know.
Yes, so that would be something, a next step we're working on. Thank you very much, Ricardo.
Thanks.
So now, Geoffrey, I hope I'm pronouncing your name correctly.
It's perfect. It's perfect. Yes. So, well, first of all, let me say that I believe this disruptive innovation in the domain we are is absolutely necessary, and it's absolutely necessary because we are in a race with giant companies which have unlimited funding. And the people we work with, whether it's OneWeb now, whether it's IRI² in the future, and even, I mean, we are discussing a lot with Lightspeed and all these kind of actors. They are really small compared to whatever Starlink is doing or whatever Amazon Kuiper will be doing in the future. So disruptive innovation is absolutely needed there, because if you follow the same rules than before and if you use the same kind of technology, you're simply dead. And we are at the moment here where, for example, we are discussing cost of terminals for OneWeb. If you want to have a decently working terminal for OneWeb, it's 10,000 euro. When Starlink is just giving the terminal to users, because they managed to lower the price dramatically. And they managed to lower the price simply because they have thousands of satellites around the globe. And so it's much simpler to connect to a Starlink satellite than to connect to a OneWeb satellite. So disruptive innovation is necessary. And also, we need to keep the pace. We need to have the same rhythm than these companies, which is extremely difficult when you're a small startup and don't have the kind of pockets they have. So I would say that in terms of difficulties and barriers, there is one which is not obvious for me, but it's really the iteration cycles that we can do. And when you don't have all the equipment and all the facilities to fabricate, assemble, and do your own things, it's slowing you down quite a lot. And we have been fighting to try to identify very fast iteration cycles for prototyping, for example, but it's still not as good as we would like. Essentially, we are able to make a new design in 2 weeks and test it in 1 week, for example, in terms of RF. But we will have a prototyping cycle of 2 months before we can measure anything. So that's really a big issue. On another point of view, anything that is related to subsystems is quite a problem, because most of the a lot of subparts that we can source come from the US, for example. So I'm talking amplifiers, I'm talking FPGAs, components like that. And this is a double problem, because we know how the American president is behaving at the moment. So you don't know how much you're going to pay these parts in 2 months. Plus, there is a problem of sovereignty, which comes also. So yeah, we don't have enough in Europe, and I believe we should have much more. And that leads me to the money issue. This is also a severe problem, because the reason why we don't have components and subparts in Europe is because companies simply don't invest into this kind of stuff. The large corporations should invest in this kind of developments, but they don't. And so we are in the process to develop our own power amplifier, for example, for the KU band, because there is simply nothing that is adapted that exists on the market on the European level. If you want to have something, you need to go to Corvo in the US, for example, and because they have quite a monopolistic position, they have very dramatic costs. So this comes to the bottleneck of the investment, because designing your own components costs a lot of money. And if you want to reduce the price of your product, you need to have components which are cost effective. So you need to make these investments if the larger corporations don't do it. So that's also a barrier that we have and that we are trying to deal with. And we are looking, for example, for public fundings to help us co-fund this kind of developments. Also, one barrier that I would like to mention is because it's here, it's our customer habits and kind of rigidity. The people we deal with, they are mostly from large companies, quite established companies, and so they are used to work in a certain way, which is not the way startups work. So you really need to convince them. You really need to spend a lot of time explaining that yes, the prototype is here. The performances are not here yet, but this is because we are working in iterations and we are each step improving our performances. And that is really when you depending on the company, some of them understand that because they are used to work with startups. Some others are really close to this kind of approach, and they want to have the final thing in their end working just perfect, and nothing else. And this is really not helping the development of startup. So finally, as a last note on the long term, I really believe that we need to help the European startups with some access to public markets. And the reason is simple. You need to have orders, you need to have volume, if you want to make the best product. And that should start with some more access to public markets, I believe, because this is not working well at the moment, neither at the French level nor at the European level, and this is a barrier for the I believe for the European startups.
Thank you, Jeffrey, for your very honest and clear feedback. Actually, listening to you, I'm almost grateful you're working on ground technologies rather than, how do you say, rather than space-based,
Space.
because I was a project manager on PCDUs, power conditioning units, for working on a factory floor for Thales Charleroi, and I recall the flight qualification cycles. I recall the ITAR regulations, and how there was a special expert who had the key to open the components. And I had even one project during EMC testing, an FPGA blew up, and how expensive it was. My project budget completely blew up because of the change. It was the price of my new Renault Twingo at that time. So it was quite of a so what you're saying is very clear to me. And also, actually, you're not only the first. Other colleagues from the EIC Space portfolio, they actually were even asking to have a webinar with large system integrators on how to work better with startups and SMEs. So this is something which I believe we should probably look in more in the long term. So next question is domains of emerging market, domains for market-driven innovation and opportunities. So let's go on the positive side now a bit, because Ricardo, that is also linked to, in your opinion, what are the future opportunities? What are the market-driven innovations? How do you see in your area, in your domain? Let's focus on the opportunities. Let's forget about, maybe not forget, but we did discuss quite a lot the barriers. So let's focus on the opportunities.
Sure. Thanks for the question. So I can only second and start with something that also my colleague here, Geoffrey, said about the fact that when you're launching a new product and you have an MVP, right, and you need to do incremental innovation over cycles, it's definitely hard to do that, right, by definition. But especially if then, like in our case, the market is new, right? So we are developing the market as we go. Our data is a new in the ecosystem. So we find ourselves all the time. The sale approach is not a conventional sale approach. It's more also a co-development, a co-creation also with our customers, sometimes even an education activity, educating our own customers on how to use the data and the potential of the data and the value for them of the data, right? Because in the end, it's about the value that they can create, the insights and the applications that you where you feed the data, and that makes me come to the main point, which is always, yes, we have a beautiful tech, but what customers want to know, what customers are interested in, and the market-driven opportunities are about problems that you can solve, hurdles that you can remove, costs that you can lower, right? And this is exactly the point, showing this value to enable new business models, to enable new use cases. Here, for example, I want to take back again the point on the digital twin, right? Conventional Earth observation is about imagery, yeah, you task a satellite to capture an imager over a certain area, right? And then you sell the full imagery to the customer, but maybe the customer is interested in a pixel of that image, right? So very low value per price. Here, by observing physical and chemical properties, you can move towards delivery of a single pixel or few pixels. Imagine that I'm taking a scene and I have a road, an agricultural field, and a nuclear plant. Those three different infrastructures or areas have different values, right? And the different customers are interested in only certain pieces of it and certain information about these different things, right? Or again, moving towards rather than on spot observing that nuclear plant, having the delivery of the temperature trends of all nuclear power plants in the world in 2025. That's what we are moving towards, right? Not anymore than asking and tasking an image, but retrieving the information that you need. And this is kind of the change in the mindset and the opportunity to deliver really higher value per price, per cost to the users and to the customers. And then again, as I was saying before, also decoupling then the capacity. The capacity of the satellite is always a bottleneck, right? And even more if you then factor in weather or unavailability, general unavailabilities, right? And that's why moving towards a model with obviously all these emerging AI techniques, now it's really possible to move towards a digital representation and when you have your data feeding into the model and training the model, then you can really control then the delivery chain and move towards a more scalable approach that enables then new businesses and new use cases and even new markets.
I see, Ricardo, your passion for AI technology and training the AI algorithms and digital models. This is really good to see that passion in your eyes. So,
thanks.
Geoffrey, your turn on this question.
Yes. Okay, so first of all, I think that I need to mention the politics and the world simply we live in, because this is driving a lot. In fact, the needs and the usage. In the past years, we were talking a lot about ESR and so on. And we did have a unique selling points with all these aspects because our technology is very low consumption, and this is something that was really appealing to a lot of partners, investors, and even customers. But now the world is changing a little bit, and we are more in well, let's say a wartime where sovereignty is the key. And again, it's driving a lot the needs and the discussions that we have and the commercial traction that we have at the moment. So more than the big trends or big innovations or big markets, really the way the world is changing at the moment is absolutely crazy in the sense that it can change in 6 months totally your business model and the commercial traction that you have at Time T. So that's my first observation. And just to let you, I mean, maybe you read the newspaper, but European Commission was discussing how to change the 40,000 terminals, Starlink terminals that are in Ukraine at the moment, just because they don't trust Elon Musk anymore. So and
with
this is
OneWeb, I recall.
yeah,
Right?
with OneWeb,
Yeah.
and OneWeb doesn't have enough antenna to do that. So you know, and so really this is crazy discussions that are happening at the moment, and this is just independent of any technological trend or whatever. It's just the way the world works at the moment. Now moving to more let's say big trends, I would say that I was saying that we are fighting against well, we are helping people fight against Starlink or the future Amazon constellation, but in fact we also benefit a lot of what they are doing because they really open markets. Of course, they leave very little on the side to others, and I have the feeling that when they start to put sensors on their satellites, Ricardo must have a good IP to be sure to be the best at what he's doing, because this is the sense of history. I mean, they will put sensors on their satellite, and Starlink is not only going to do connectivity in the future, for sure. When you launch thousands of satellites, you want to put the maximum of payload on it, but they are really opening new use case in our case. And when you see that 10 years ago, you were discussing with people about, in-flight connectivity, in-train connectivity, not mentioning even in-car connectivity. Nobody was talking about that. Nobody cared about that. But when you have Starlink coming and starting to put antennas on planes, on trains, on trucks, on boats, exactly. And really, it has been completely changing in 10 years the ecosystem of the satellite connectivity. We are really going from broadband, broadcast, sorry, which was essentially the easy market of satellite operators, to something which is really real-time connectivity, and that's extremely interesting for us and for a lot of other players. New use cases, new markets, and I'm quite sure that, for example, the mobility market for us is absolutely interesting. We know that most likely in a few years there will be SATCOM terminals in cars, just for security and software reasons. You need to have the most cost-effective technology for that. You need to have the most low consumption technology for that, and we have a very good positioning in this. So for us, it's also a lot of new opportunities and a lot of new use cases that are opened by these big constellations.
Thank you very much, Jeffrey, for your clear and concrete. I actually think it wouldn't be 6 months. I think it will be less than 6 months, probably 3 months business models will have to change. Things are moving so fast,
yes,
so
that's right.
dynamically.
That's right.
So I would like actually now to focus. I know I had sent one question about the risk and opportunities for disruptive innovations, but I think this question links very much to the lessons learned. For me, it's very important that I hear what are the lessons learned. But before we dive into your recommendations on lessons learned, I want to ask the audience, do you have any questions which you would like to raise to Ricardo or Geoffrey? Let's see if there are any hands raised. Well, I don't see any hands raised. So in this case, I would jump with the question why we came today. In your opinion, what are the lessons learned? What you have learned a lot of lessons as Constellar. I mean, technology, market, you were talking about, you're building the market, you're developing the market as you go, pretty much operational. So Constellar is one of the mature new space companies, let's say, and you're also active not only in our program, but also you're under EIC Cube program. You launched recently the Skybe on the 14th of January. You have been extremely successful as a new company in the recent years. So can you just share with us which are the major lessons which you learned, Ricardo?
Absolutely happy to. So, well, certainly, and what I was also hinting earlier is that there is always a trade-off to be made on everything, but in this case, a trade-off between cost and speed and reliability, availability, safety, operability, performances. So obviously one would want the best, the maximum reliability and performances with the best speed and cost, but that is obviously always not always possible. So the lesson here is, first of all, as I was saying, to blend different approaches that allows you to get the best of different worlds, to then test fast, parallelize your activities, keep it lean. That's definitely also big lessons that we learned. It's better to have, yes, disruptive innovation is important for what we said before. It can come at different levels and in different elements, but you also need to have an incremental innovation approach for those performances and parameters that you can build up in time, because it doesn't make sense to wait years to launch product in the market to have the best one, but rather it makes sense to launch something imperfect faster and then incrementally improve on that. Then automation, I think, is also a key lesson. Automation is a key in all aspects, space and ground and operations. And also the interfaces to external party in terms of really also on automation there, but also on control over the critical supply chain. That's also a very important lesson. As I was saying, be lean, outsource non-critical IPs, and develop what really needs to be in-house. And then always get to a model where that is scalable. For example, a platform, as I was saying, over a vertical only dependency. And in my view, just to conclude quickly, is that what works very well for us is having a pragmatic approach. Having a pragmatic approach over the entire design, development, and verification cycle, right? Readapting the process to our needs. Same for the make-buy strategy, a lean one, and then finally really co-develop and co-create with our ecosystem, with our suppliers and with our customers, right? Yeah, that I stop here. I could
I
go
like
on.
it what
Yeah.
you say, Ricardo. Co-develop and co-create
Mhm.
with our suppliers and
Yeah.
with our customers.
Yes.
Something which we did witness in the early days of ISS commercialization of the space station, that space station was built for scientific requirements. And then 20 something years ago, when they started, when there was, let's use the facilities on board the Columbus module for commercial end users. Commercial end users had very low interest because the facilities hosting, they were built actually mainly for scientific reasons and not commercial ones, except for the European RORAC. So that is a very, very strong lesson, I do believe. Another lesson which I think is good to kind of not to forget is also changing technical requirements from institutional customers. This is also has quite of an impact
Indeed. Yes.
for an SMEs and startup. And I think
Absolutely.
Geoffrey did talk earlier about it. So Geoffrey, the floor is yours.
Yes, thank you. Well, I've assembled a list of lessons learned. It's not all the lessons because otherwise it would be a full pile. But both as an entrepreneur and for related more to product and market. But I want to come back on what Ricardo was saying, because this is absolutely true that first of all, when we come from very technical background and when we come from especially from academic institutions, when so-called deep tech, there is a tendency to want to have the perfect thing working with the perfect science and so on. And really, what I realized moving from academia to the startup is that you really need to simplify whatever science you've been developing before. You really need to simplify the ideas, and in fact, turning a scientific or technology into a product requires much more than just nice science, and it's very, very different. And there is a huge step in turning a technology or an idea into a product that people should be aware of. It's a huge work which is taking a long time, and if you don't simplify whatever was your science initially, it's very complex, and that goes also with the market, which is going very fast. The people are not waiting for you. We are talking about scales of 2, 3, 4 years for projects, but in 2, 3, 4 years, I've seen 15 new competitors in my domain. It's amazing. Each time I go to Washington at the satellite show, we have 2 new competitors or 3 new competitors. And so hopefully they don't have this disruptive technology that is going to kill us. But the faster you go on the market, the better it is, because you never know what's going to come next. Then I think what is very important and what has been for us quite pivotal is really to work hand in hand with the final customer. You don't want to work on your side and to develop your technology in your bubble and go at the end of the day discuss with the customer, because it's of prime importance really to have the inputs, the specs, and the feedback of your customer on an everyday basis. And just for example, I started the discussion with Intelsat in 2019. We didn't have an antenna. We only had slides to share. Just showing, okay, this is what we could do with our technology, and we started discussing with them. And it was informal discussions, now and then. But at the end of the day, they became an investor. We are co-developing products for them, and this came with a mutual relation, which brought us a lot as a startup. So the sooner you can start to work with a customer, I believe the better. Also, there is something that on a little bit more negative side, which is very important for me, is to be always aware that whatever you're doing, it can all fall at once. And for example, just a small story about, we were developing something with a big corporation, and we were starting a joint venture with them. And it was in the final rounds of signing this joint venture, and then the market dropped on the stock exchange, and they decided to cut any innovation in the company. And so, although we were finalizing the last point of the joint venture agreement, it was no longer the part of the story. So really, when you think you're there, wait to be there before you take any decision, because everything can change in 1 second for startups. And for this reason also, I believe that the holy grail, which is to be focused on a single development all the time, which is what people teach you when you're in a startup. It is important to be focused, but it is also important to have 2 legs when you develop your company, because investors want you to have a single focus, because they de-risk themselves by investing on several companies. But this is your company, and you need to make sure that if one development is failing, you have something else to stay alive at the end. So don't necessarily take all the advices, the perfect startup advice that people give you, because they are not necessarily true as an entrepreneur. And finally, I think, well, lessons learned. It's more from a personal point of view, but I think that so this will be my my next to last point. The people you work with is extremely important. Choose people very wisely. You need to choose people who have energy and who can transmit energy, not people who take your energy, because it's extremely painful to work with this kind of people, and starting a company, starting an adventure like that is really taking a lot of energy. So if you don't have the good people around you, the complementary people with the good mood and so on, it's a real hassle. And finally, just I think that we are saying a lot about the lack of capital and the lack of funding that there can be in Europe, but there is also a very rich ecosystem of public funding, and you need really to take benefit of that. And EIC is a perfect example because it's really, I believe, the a super good system where you have a grant and the equity is bringing in investors because they trust the European Commission, and so it's really helping you to attract investors. But there are a lot of other programs in France. We have the BPI in every country that there are similar systems, and yes, the funding is more difficult to get from investors, but public funding is something that is quite efficient in Europe. So and we have used it a lot, and this was good for the company.
Thank you, Geoffrey. What I hear is it's important that institutional organization actually de-risk the high-risk innovations,
Yep.
but then in such a way they de-risk it that you actually have the freedom to develop your own use cases, attract your own customers, and mainly attract your own investors. So this is very, very important. Your area, flat panel antennas, I believe, has been a very hot topic already since maybe 2018, 19 with high throughput satellites. I mean, I do recall the Kymeta, the Swarm 45, but which have much less performance, I believe. So there is a lot of interest. So I'm very glad to have a project like you in our portfolio. I like your advice. Don't take the advice which you always like. Often we have these not experts, or how do you say, or investors who say, oh, please focus only on one thing, but I do think you're right. You need to have more than one or two legs. So because the markets are changing so quickly, the ecosystem is developing so quickly, and you need this agility to be able to adapt and move as soon as possible. And it is also very challenging, I believe, for projects, particularly in the space industry, when they are developing lower TRL levels, to be actually able to start to commercialize. And here comes the benefit of technology demos. Having technology demos, and here that's what you said, work with your end user, and both of you said that, co-develop, co-create with your suppliers, customers, and work from day one. Because only through technology demos, you can see, and they can see what are their own needs, and they can see what are their metrics. So I would like to thank to both of you, and I would like to see if are there any questions from the audience towards our guests? I don't see any hands raised, so I would let you all go to have lunch because it's already lunchtime. I would like to thank you. Oh, there is a question. Oh, no. Okay, thank you. So it's, I would like to thank you to both of you for your excellent presentations, for your honesty, for your directness, and for sharing your experience, very valuable lessons learned. I look forward to seeing you on the 3rd of July in Brussels. And I want to thank also Stefania and Jessica and Joao for their excellent support. Thank you.
Thank you. Thank you very much.
Bye.
Bye-bye.
Thank you.
Thank
Bye.
you.
Bye-bye.
Thank you.
Bye-bye.
Thank you very much. Bye.
Bye.
Thank you. Thank you.